Problem 4-52. Is x equals -1 a solution to the inequality 2x squared plus 5x minus 3 is less than or equal to x squared plus 4x plus 3? What about x equals 5? Show how you know. Then find 3 more solutions. Okay, first thing I want to point out on this one is this is a preview problem. We have not talked about this in class. Okay, this is just to get you thinking about this as we move into working with more inequalities over the next couple lessons. So like I said, if you've not seen this in a long time, or if you've never done this before, that's because it is a preview problem. So we should be able to determine if it is a solution to the inequality here. Just like any other equation or anything like that, we want to plug in this value to see if it makes it true. So let's do that with the first one. Is x equals -1 a solution? So I'm going to take my inequality here and I'm going to plug in the -1 and we're going to see what our values are. So 2 times -1 squared plus 5 times a -1. And then we have -3 is less than or equal to -1 squared plus 4 times -1 plus 3. Make sure you're careful. Even I make mistakes sometimes when I'm copying things down. So I do believe that all looks like I've got it copied right. I didn't alter any signs or do anything like that. So let's just simplify using order of operations. -1 squared is going to be 1. So 2 times 1 is going to give us 2. We have plus 5 times -1. That's like saying -5. -3. On the other side here, we're saying -1 squared is going to be 1. 4 times -1 is -4. And we're going to add 3. 2 minus 5 is -3. -3 more would be -6. So we have -6 is less than or equal to. 1 minus 4 is -3. -3 plus 3 is going to be 0. -6 is less than or equal to 0. This is true. Let's make an exclamation point. Yay, this is true. So we know then that, yes, x equals -1 is a solution to the equation. I'm sorry, the inequality. Just like anything else, if this had not been a true statement, then it would not be a solution. Let's check when x is 5. If we say 2 times our 5 squared, you can type them in the calculator too, just make sure you're careful, plus 5 times 5 minus 3 is supposed to be less than or equal to 5 squared plus 4 times 5 plus 3. 5 squared is 25 times 2 is going to be 50 plus 25 minus 3. And we're saying that's less than or equal to 25 plus 20 plus 3. This would give us 72 on this side, and 25 plus 20 is 45, plus 3 more is going to be 48. So that is not true. So false. Our x does not equal 5 in our problem here. So 5 is not a solution. Okay, this is how we know because we could plug it in, and if it was a solution, it would make the statement true. Now they ask us to find 3 more solutions. Now, one way we can do this here is we can take this and we can solve this. Let's do that. This is a little bit of a preview, but if you take the time to do this here, it may help you out when you get to that next lesson. So if we have 2x squared plus 5x minus 3 is less than or equal to x squared plus 4x plus 3. Well, I'm going to focus right now on the equals part of this. I'm going to focus on that equals part there, because I could solve this for x and figure out here what values of x make these equal to each other. And since they are quadratic, chances are there's probably going to be two solutions. There may not be, but we'll see what happens. Let's go ahead here, and I'm actually going to just treat it like it's an equation. 2x squared plus 5x minus 3. I'm going to treat it like it's equals x squared plus 4x plus 3. So if we're solving this, we would subtract our x squared from each side. Subtract 4x from each side. Subtract 3 from each side. So 2x squared minus an x squared is going to give me just 1x squared. 5x minus 4x is going to be x. Negative 3 minus 3 is going to be negative 6. That should equal, well, since I did the inverse operation of each of these here, or, got rid of them, it should equal 0. If we continue to solve this, we can look to see, does it factor? And it does. And we should be getting better at factoring here. We've had a lot of things we've needed to factor lately, and you should be getting better at it there. You should be getting faster. You can still use the generic rectangle if you need to, but if we think about our values of negative 6, or our factors of negative 6, that differ by 1, a positive 1, we know that we should have x plus 3 and x minus 2. Use our zero product property. So if the product is 0, that means either this value has to be 0 or this value has to be 0. So figure out what value of x would make the whole thing equal 0 there. So you get negative 3 or x equals 2. So if we took either of these values and we plug them back into the inequality here, they should make them true. And I'll go ahead and just do one of them just so you can see that. We have 2 times, we'll do the negative 3 because I know that we all love negatives, so I'll do that one for you. You can check 2 on your own. So I'm checking it in my actual inequality here. Make sure that when you plug in a negative, you put parentheses around it. So negative 3 squared is 9. 9 times 2 is 18. Minus 15 minus 3. 18 minus 15 is going to be 3. 3 minus 3 is going to be 0. That makes sense because I solved this when y was 0 here. My x-intercept would have been negative 3, 0. Same thing on the other side. We've got negative 3 squared is 9. 4 times negative 3 is negative 12 plus 3. That also gives us 0. This is a true statement because of the equals. So right now we know that negative 3 works. So I'm going to write that here because we need to find 3 additional answers or 3 solutions. So the first one we could say is negative 3. We also know that 2 will work. And we've already said up here that our negative 1 works. But we need to find one more additional solution. So I'm going to take this here, and I'm going to have you kind of visualize. And this is an important part because this is a big part of the lesson that you will do later on. Maybe if we plant this seed, it'll help you out a little bit. So if I have a number line here, and I'm going to consider these to be my boundary points. I've got negative 3, and I've got positive 2. I know that negative 3 works. I know that positive 2 works here. So we also have, values. I think 0 would be located in here. Now we know that -1 does work, right? So we knew that -1 was a solution. So if -1 is a solution, and we've got solutions on either side of it, that means that all of these values in between -3 and 2 will be solutions. Outside here, we tried a 5. We tried 5 over here, right? We tried 5, and 5 did not work. Okay, what do you think is going to happen over here? Do you think they will work or not work? Let's say you plug in a -4. Would -4 work in there? We'd have 2 times -4 squared plus 5 times -4 minus 3 is less than or equal to -4 squared plus 4 times -4 plus 3. This is going to be 32 plus a -20 minus 3. That's going to give us 9. -4 squared is 16. Minus 16 plus 3 would give us 3. Is that true? No, that's not. It's going to be false. So none of the numbers outside of -3 will work. So our solution here, we could choose any value as long as x is greater than or equal to -3 and x has to be less than or equal to 2. Now this can also then be written as -3 is less than or equal to x, which is less than or equal to 2. So choose any value from -3 to 2 and it should work. Why don't you even try 0? That would be an easy one. Plug in 0 here, you're going to get -3 is less than or equal to +3. That's true, so let's just go ahead and throw 0 in there. Okay, so we've proven that x equals -1 works. We talked that -5 does not work. And we've kind of shown how we know by plugging it in. And then we found 3 more solutions here. We chose -3 and 2 because those are boundary points there, and they make the equation true and equal to itself. And then we found that the other points lie in between them there. You'll see that when we get into graphing inequalities and things here on the calculator, you'll see them even easier or even quicker there. So remember, this is just a preview problem. Don't freak out if you don't fully understand it, but you should be able to grasp some of it. It's problem 4-52. Thanks for watching. I hope this helps out. This is Mr. Boyd signing off. Have a great night.